Hey, what's up, guys? We're here with day 7. Today we're going to be working on applying the derivative. Shout out to our 30 subscribers out there. Way to go. We'll see what, I'm still thinking about what we're going to do for that. Anyways, keep it up. You guys are doing an awesome job. When we apply the derivative here, the limit definition of a derivative, it's going to help to write down that equation for f prime of x, the derivative of the function f. So we can see here we got f prime of x equals the limit as h goes to 0 of the quotient f of x plus h minus f of x all over h. Now again, this just looks like a whole bunch of letters and a bunch of nonsense, but where we got this from is from the secant line. 2 points, x plus h and x. We find the slope between them, and to get a slope of a tangent line, we shrink that h, that distance between the 2 points, down to 1 point, so we can essentially find the slope with just 1 point. Okay, so this will help us find the slope. This will give us a function that will give us the slope of the tangent line of our original function, f of x, at any point we want. So just buckle up today. The way that we do derivatives right now is going to be really tedious and difficult. It's going to get a lot easier, and what I want you guys to look for in this video is I want you to check to see what's happening here. What are maybe some shortcuts we could take to make doing the derivative a much less painful process. Once again, I'm working on this board that sometimes misreads my marks on my pen, so bear with me. If you notice that f prime kind of looks a little funky, I'll try and fix it here. Okay. So let's start with a function. Our original function we're going to look at is this. So we have the function here, f of x equals 2x squared minus 8x plus 1. If we think about that, we know that that function is going to be obviously a quadratic here. It's going to be a quadratic that opens up. Other things we know about it is it has a y-intercept of 1. Let's just take a look at this on a graph real quick. So again, here we see our function. We see that y-intercept of 1. We see it's a quadratic. It's a parabola, right? It's opening up. All things that we would anticipate from working with quadratics in Algebra 1 and Algebra 2. So let's talk about finding the slope at various points on this graph, right? I want to know, what is the slope of the tangent line right here? Or maybe what's the slope of the tangent line over here? Or maybe what's the slope of the tangent line right here? So if we want to find the slope of this, the instantaneous slope, we're going to apply the limit definition of a derivative, and we're going to come up with a function, f prime of x, that's going to allow us to find any tangent line anywhere on this graph. So let's do it. Okay, to apply the limit definition of a derivative, I need 3 things. I need to consider f of x plus h, I need to consider f of x, and I need to consider h. Now h is the easiest to work with because we're just going to let h be 0. F of x we already have right here. The one that I don't have an expression for is f of x plus h. So let's go ahead and write down what f of x plus h would be. Well, all we're going to do is look at our original function, f of x. We see f of x is 2x squared minus 8x plus 1. What I'm going to do is just sub in an x plus h everywhere I see an x in f of x. And when I do this, since I'm subbing in a binomial, I want to make sure I put it in parentheses. So f of x plus h is simply going to look like this. So here I see an expression, or sorry, an equation for f of x plus h. I see that f of x plus h is really 2 times x, the quantity x plus h squared, minus 8 times the quantity x plus h plus 1. It looks a lot like f of x. It's just everywhere we see an x, we're plugging in an x plus h. Okay. Now we're going to execute this derivative. We're going to write this. Now when you do this, just fair warning, make sure you leave yourself lots of horizontal space to do this, because this is going to get really ugly really quick. But all we're doing is following, right up here, we're just following our definition of a derivative. We're just following this formula. So we're just going to replace f of x plus h and f of x with what they are and see what happens. So watch as I write this out. So again, we knew this was going to start looking ugly, but take a look. Those first terms I wrote, the first 3 terms we see there are 2 parenthesis x plus h squared minus 8 parenthesis x plus h plus 1. That is simply f of x plus h. I subbed in for my limit definition with what f of x plus h is in this particular problem. Then I have to subtract f of x. What I want to draw your attention to here, that's a point of mistake for a lot of students, is that you need to put that f of x, if it's a binomial or a trinomial like it is in this case, make sure you put it in parentheses. It's really, really important that we're subtracting the quantity of f of x, and f of x is a trinomial here. So parentheses around that 2x squared minus 8x plus 1, very, very important. All over h. Okay? Now when we do a limit, we always want to plug in 0 first and see what happens. Well, what we're going to get is all those x plus h's in the first 2 terms there are just going to turn to x plus 0. They're just going to turn to x. So we're going to have 2x squared minus 8x plus 1 minus 2x squared plus 8x minus 1. All those terms are going to cancel each other out, and we're going to get a 0 on top. And obviously, we're going to get a 0 in the denominator. So we get 0 over 0, which means the function's undefined there, but we can still find the limit there. That limits deal with 0 over 0, whereas functions don't. So let's see if we can manipulate this thing, just like we did in day 2 and day 1 videos. Let's see if we can manipulate this thing and get those h's to cancel out so we can actually come up with a function for a derivative. So what I'm going to do here is I'm going to FOIL that x plus h squared and distribute the 2. I'm going to distribute that negative 8. I'm going to distribute the negative sign in front of the f of x. Again, this x squared plus 2xh plus h squared comes from foiling x plus h times x plus h. Remember, x plus h squared is not x squared plus h squared. it's x squared plus 2xh plus h squared. Don't forget your foiling there. Okay? I haven't distributed that 2 yet, but I am going to distribute this negative 8 here. And make sure you are bringing that negative along with for both distributions here. Okay, notice I distributed that negative 8 to both the x and the plus h, so I got minus 8x minus 8h. Plus 1 I didn't have to do anything to. But then notice I distributed that negative sign to all 3 parts of that trinomial. So I ended up with a negative 2x minus 2x squared plus an 8x minus a 1. The whole thing is over h. I need to do one more distribution here to get this into my final form, and that's distributing that 2. So I'm going to go ahead and do that now. Follow along. Okay, now I have fully expanded that top function there, and it looks like a complete disaster right now, right? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 terms on top. That's a lot of terms, okay? But after we fully expand this, just like we did with limits back in the day, a few days ago, we want to see if we can simplify that top, if anything cancels each other out. And in fact, a lot of things will here. So let's just strike through all the things that are going to cancel each other out. As a hint for this for the future, all of our f of x terms, that was those last 3 terms, all of those are going to cancel out. Okay, but there will be some stuff remaining here, so let's take a look. When we strike through things, it's really important to do that carefully and make sure that we maintain any signs of the things that remain. We make sure we see whether they're plus or minus, because that's going to be really important here. So again, those 6 things we're all able to cancel out. The minus 1 with the plus 1, the plus 8x with the minus 8x, the negative 2x squared with the positive 2x squared. If you're doing this and you're finding that things aren't canceling out, you probably had a distribution error when you were expanding it. So go back and check that if you ever have a mistake with it. Okay, so let's clean it up now. I'm going to write this thing in a much simpler sense below. All right, so that cleaned up quite nicely. We're left with 3 terms on top and 1 term on the bottom. What I want you to notice now is that all of those terms on top have an h in them. All the terms that didn't have an h canceled out in that last step. So we're left simply with terms that have h in them, which is a thing of beauty because now we can factor out an h on the top, and we're going to be able to cancel out that h that's in the denominator and get rid of our problem of 0 over 0. So watch as we do this. So again, after I factor out that h, I'm left with 4x plus 2h. Make sure you see there's still an h with that 2, because it was a 2h squared originally, minus 8 over h. So I cancel out my h's, and I'm left with this. Now, after we canceled when we did limits, our next step was, well, let's try plugging back in. Hopefully we got rid of our 0 over 0 situation. And when we plug in 0 for h, it's going to cancel out that 2h term, and we're going to be left simply with 4x minus 8. And right now, we have just found our first derivative. Now, this is really a lot of work to get this. What I want you to do is take a look at that answer of f prime of x equals 4x minus 8. Sorry, 4x minus 8. Take a look at our original function. Up here of f of x equals 2x squared minus 8x plus 1. Is there a shortcut to go from f of x to f prime of x? Think about it. See if you see anything. Okay? But what's more important here, we'll learn the rule and it'll be super simple to get f prime in the future. But for right now, we had to go through quite a process to get there. But let's talk about using this. Let's think about f prime of 1. How would we evaluate f prime of 1? First off, we're going to plug in 1, right, into 4x minus 8, and we're going to get a number, and then we're going to talk about what that number means. So first off, let's do f prime of 1. So I'm just going to go ahead and do this. You can do it as I'm doing it. And we get a value of negative 4. Here's the cool thing. What does this mean? This means that on our original function f, at the point x equals 1, the slope of the tangent line has to be negative 4. So this means, again, the slope of the tangent line to f at x equals 1 is negative 4. If I wanted the slope of the tangent line to f at 3, I would have plugged in 3 for x. And I would have gotten 12 minus 8 is positive 4. If I wanted the slope of the tangent line at x equals 10, I'd plug in 10 for x, and I'd get 40 minus 8 is 32. So I can find slopes of tangent lines anywhere once I get this function f prime of x, the derivative of f of x. Let's take a look back at our graph and see if this makes sense. So take a look at where I placed the cursor. I tried to place the cursor at an x value of 1 on our function f of x. Now, what do we notice about a tangent line? If we drew in a tangent line there, does it look like it would be negative 4? Well, it certainly looks negative, right? If we connected a tangent line there, that's going to be a negative slope. And it looks relatively steep, so negative 4 seems like a good answer. Now, the cool thing about these calculators is you can check. Here's what I want you to do. To do a derivative of a graph on your calculator, we're going to be doing this a lot this year, you hit the second button and then Calc. In our choices here, we see things that we've used before, like finding a zero, finding a minimum, finding a maximum, finding out where lines intersect. But if you look at number 6 there, we see dy dx. dy dx is another type of notation for derivative. So let's select 6. And when we select that, it's going to want us to input a number that we're going to do the derivative at. Well, we just found the derivative at the point 1, so go ahead and click 1 and hit enter. And take a look. It says dy dx equals -4. So that's telling us that the derivative, the slope of the tangent line to this graph, is -4, which is the exact same value that we calculated in our work. Okay. We'll look a lot more at this later. What I want to do is, here's what we're going to do today. I'm going to pose a question, f of x, and I want you to solve it, and then I'll just solve it in the video after. But take a shot at it. Try and solve it all the way through so you can get f prime of x. So the new function here is f of x equals -6x squared plus 3x minus 5. So what I want you to do here is go ahead, apply the limit definition of a derivative. So you're going to need to come up with an f of x plus h, and then you do limit as h goes to 0 of f of x plus h minus f of x over h, and solve to see if you can solve for this derivative function f prime of x. So go ahead, pause it here, solve it out, and when you're done, unpause it and watch my work and see if they match. Okay, we're back. I'm going to go ahead and just solve this thing all the way through, one shot, quickly. Here we go. Oops. So take a look. Did you get the same answer I did? Did you make a mistake like I did in the middle there? That's okay. People do that. We just got to catch them. So there's our derivative, negative 12x plus 3. Once again, take a look at negative 12x plus 3. Compare it to our original function, negative 6x squared plus 3x minus 5. Do you see the pattern? Think about it. We'll talk about the pattern later on. Thanks for watching, and as always, have a good day.